All right, welcome. Now what we're going to do is we're going to introduce the definition of a finite geometric series, and then we're going to derive the formula for finding the partial sum for a geometric series. Okay, so the definition, the nth partial sum. So this is definition. We take the nth partial sum. Remember when we talked about this before with arithmetic series, same idea. So a partial sum, same definition. But the partial sum here is the first n terms of a geometric sequence. So if we take the partial sum of the first n terms of a geometric sequence, we call that a finite geometric series, just like a finite arithmetic series. Okay? Same thing. Now, how do we derive the formula for S sub n? Okay? Well, the first thing we're going to do is we consider a series, okay, a geometric series. So consider S sub n. So let's consider the following series. So S sub n, and that's going to equal A1 plus A1R plus A1R squared plus A1R cubed, and so on. Okay? Now, let's suppose that we subtract the same thing but multiplied by r. So suppose we subtract r times a sub n from s sub n. So now let's write that out. Okay, so we would get s sub n is equal to a1 times r plus a1 times r squared plus a1 times r cubed plus dot 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 plus a1 r to the n minus 1. Now what we're going to do is we're going to take r times that. R times s sub n is just going to be the same thing, but now with the multiplied through by r. So that means that we're going to get a1 r plus a1 r squared plus a1 r cubed plus a1 r to the fourth plus dot 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 plus a1 r to the n. Now what we're going to do is we're going to subtract, right? Just like that. Now what we're going to do is when we subtract, we get what? We get S sub n minus r S sub n is equal to a1 minus a1 r plus a1 r minus a1 r squared plus a1 r squared which is going to be A1R to the n minus 1 power minus a sub 1 times r to the nth power. All right, now, this is where the magic happens. Because if you notice here, everything in between the first term and the last term, everything in between a sub 1 and a sub 1 times r to the nth power, if you notice, they all are the same, but with opposite signs. So you've got a minus a1r here and a plus a1r here. You've got a minus a1r squared here, plus an a1r squared here. And then you got a minus, and it keeps going. So all of the middle terms start canceling out. So this will cancel with this one cancels with this one, and then this one will cancel with the next one, all the way down to the second to last term. And what we get is we get s of n minus r s of n is equal to a1 minus a1 times r to the nth power. Okay, now, let's go back to the top here, because we're right at the end. Okay, so what do we end up with? We ended up with s of n minus r times s of n is equal to a sub 1 minus a sub 1 times r to the nth power. Now, we're solving for s of n, so I'm going to factor out s of n here. So that means s of n times what? 1 minus r is equal to, I'm going to factor out the a1 here, so that's a1 times 1 minus r to the nth power. And so, of course, I'm going to divide both sides by 1 minus r, and we're done. So we get the partial sum, the formula for the nth partial sum is going to be nothing more than the first term times 1 minus the common ratio raised to the nth power, all divided by 1 minus the common ratio. And so here is our formula for finding the nth partial sum of a geometric series. Have a great day.